to ensure the failure mode studied in the FMEA will not lead to a system failure. So the 4-tree analysis is trying to make sure that the failure mode that was being discovered by the FMEA method is not going to lead to a catastrophic failure of the process. So it's a kind of a top-down analysis of a system failure. And when I mean a top-down analysis is that when going to look into the analysis or when going to look into a process, it's been understood already that a particular unit of the process is going to fall. So while the process is still going to start, and a preventive mode or trying to find a way to prevent any failure is going to be taken care of. And it's mostly used in a nuclear plant. So and between the FMEA and then the 4-tree analysis, a large logic diagram are being created between low-level failures and the high-level failures. And the essence of doing this is just to try to prevent failures in the plant. Then another one is the hazard and operability study, the HAZOP. This is widely used in chemical process industries. And it's a kind of different from what I've just said before. It's a kind of an outside-the-box analysis. And they have to do mostly with the human factors. Like most of the ones that I mentioned before is something that have to do with the process. Looking at the process designs or looking at the process himself and trying to analyze the possibilities of failure in the process. But this HAZOP had to do with more of something that is outside the process. It's something that have to do with the human factor. And then is more efficient than the FMEA and the FTA. And the first step of this HAZOP is to try to identify the intentions of the process. For instance, trying to identify that the main intentions of an ethane cracking process is to produce an ethylene. And then the next guide, a word or a possibilities. Things are being used in order to be able to understand the consequences of some of the outcomes. For instance, the words like no, none, or something like that. Okay, let us take, for instance, there's a table here, table 24.5. Actually, we got it from the textbook. And it's talking about assuming there is no flow, there is no steam, the guide word no, and then assuming that there's a deviation, assuming that there's no steam in the process, and then the causes, the blockage in the line, and the consequences, and then the action that need to be taken. So the essence of this is just trying to find out the possibilities of a human failures or things that can be able to happen in the system, which is not part of the system design itself. And then the OSHA requires that a proper action be taken in a timely manner, and all process hazard analysis be updated at least every 5 years. So these are some of the requirements of OSHA. Then there's this Dow Fire and Explosion Index and Chemical Exposure Index. Actually, this was being developed by the Dow company in the 1960s, and it focuses mostly on fire and explosion, its causes, and then quantify its impact. So if the fire and explosion index is just like what we have on the board. It kind of looks into a process, and then when it looks into a process, it tends to quantify or tends to define the possibilities of causes of fire and explosion in an industry. Actually, this index is so much specific on fire and explosion. So let us take, for instance, in an ethane cracking process, most of that's the most volatile or the most explosive aspect of the chemicals that will be coming out of there, something like ethane. So that one is going to be used as a case study. It's going to be, the possibilities and the effect of an explosion is being looked into and is being quantified. And then the essence of this index is to appropriate a kind of a figure to the impact that is going to be experienced from the explosion. Then from there, a kind of a loose control credit factor is being created. And the essence of this loose control factor is to look into all the possibilities, assuming if there exists hazards, and then the consequences, the downtime, and then the effect that is going to have on the income of the company. And then at the end of it, the process unit risk analysis summary is being conducted. So because of the explosions, or because of whatever the factors that must have happened in the plant, a risk assessment, a summary of that is being taken. Actually, all these things is going to help the company to prepare ahead of an eventualities and map out some funds for that. So another one is the Chemical Safety and Hazard Investigation Board, and this board was being created by the Clear Air Act Amendment of 1990, reference 7, section 112, R and 6. Actually, it was being created in 1990, but actually it was not being properly funded till 1998. Politics. Actually, this is an independent scientific and investigation agency with regulatory and with no regulatory and enforcement duties. The essence of this board is just to try to investigate. Is an independent investigation agency, and their duties is to try to investigate, determine, report to the public in writing the facts, conditions and circumstances and causes, probable causes of an accidental release resulting in fatality, serious injury, or substantial property damages. So the essence of the board is to investigate, and most of the times, most of the investigations are not being done by them. They collect data from other investigative bodies, and they put it together, and then they now review it to the public, trying to give an assessment of what must have happened. So you received reports from the National Response Center, the EPA, OSHA, and DOT. And it creates a chemical incident report center where data are released with other safety organizations to seek and determine the root cause of accidents with focus on avoiding future occurrences. So they collect data from other agencies like the National Response Center, the EPA, the OSHA, and the DOT, and other environmental agencies, and they put these data together, and they kind of brainstorm and give ideas and give suggestions, and they publish some of these things in their data. They have a website which is at www.chemsafety.gov. So another one is inherit safe designs. Normally in a process or a unit, there's there's safety measures that is being adopted. There are safety measures that is being attached to it. So, but despite that, there's a tendency that accident will still tend to happen. So, and the essence of this inherent safety design is to streamline a process to eliminate hazards. So, and it's more of, in a layman's way of understanding, I would say that this is something that have to do with an individual or somebody that is operating in the process. Despite the fact that everything is being taken care of, you need to have a kind of something that have to be relaxed back on. So, and then in some of the ways that this can be done is trying to find a substitution in a process. Assuming, let us look in a process that requires something that you might use something like a gas, something like ethane, or let us take for instance in a boiler. There are the possibilities that you might use a gas or a diesel oil in a boiler, and gases are most of the times very explosive. You might decide to use something like a diesel in order to be able to prevent the aspect of the hazard. Then intensification, trying to intensify or trying to find more ways in order to be able to take away hazards from a system. Then attenuation, trying to reduce the temperature or trying to alter the modifications or trying to alter a part of a system in order to make it to look less hazardous. And then containment, assuming that what is involved or the things that might be able to cause an accident, there's no possibilities of trying to eliminate it. Another possible way is trying to contain it. For instance, gases, we need to have